Okay, so quickly talk about compound angles for tan. Remember yesterday we learned the compound angles formulas for cos. They're over on the sideboard. Cos A plus B is cos minus a sine. A minus B is cos plus sine. So remember the operations are opposite for cos. And then for sine, we have for A plus B, it's sine A cos B plus cos A sine B. And for sine A minus B, it's sine A cos B minus cos A sine B. So those are over on the sideboard. So now we're going to add the two for tan. So we're going to talk about tan A plus B. Well, of course, remember the grade 11 identity that says that tan is equal to sine over cos. So why don't we change this into sine A plus B over cos A plus B. And of course, we're going to apply the double angle formulas, or the compound angle formula, excuse me, for sine and cos. So sine A plus B, have these memorized, is sine A cos B plus cos A sine B. That's coming right from the sideboard and from yesterday. And then the compound angle formula for A plus B is cos, so cos A, cos B, opposite operation, minus sine A, sine B. Okay, so now we don't want to use that formula. That's way too much to memorize, so we're going to, and plus if you had to substitute in A and B, you'd have to substitute a ton of stuff. So we're going to try and simplify this into a much easier formula. So this next step, there's no way you would have known this, and I didn't know how to do this. But what we're going to do is divide every single term by cos A, cos B. Why? Well, somebody figured it out. That's why. You'll see what happens when we do it. So they went fiddling around and they probably divided by a whole bunch of things to see if they could make things easier. But they settled down on this. And plus, if you have sines and you divide by coses, they become tans. So someone figured out that if you divide everything by cos A, cos B, things seem to work, and you'll see what happens. Okay, so let's do that. Again, I'm not changing the question because I'm dividing both the top and the bottom by the same thing. It doesn't matter. So each one of these terms is going to become its own little fraction. So sine A cos B is being divided by this thing in red, cos A cos B. And then this term over here, cos A sine B, is going to be divided by the thing in red, cos A cos B. That's just the top. Now the bottom. So each term on the bottom, oh, don't need that equal sign. So cos A cos B divided by, itself, cos A cos B. So that's good. And then the other one, which is sine A sine B divided by cos A cos B. So each one of these things gets divided. All right, if we do this, we'll see that a bunch of stuff's going to cancel, and it's going to make the question a little bit easier. So let's look in the first part up here. So we've got sine A cos B divided by cos A cos B. They're both being multiplied by cos B, so those will cancel. In the second term over here, you notice that there's a cos A on the top divided by a cos A on the bottom. Those will cancel. This one here, it's the same thing. It's cos A on the top, cos B on the cos A on the top, cos A cos B on the top, on the bottom. So that's going to cancel. Remember, canceling means dividing and equaling 1. So when you divide it by itself, this whole thing's going to become 1. And then what about the last one? Well, there's nothing that cancels. Sine A, there's no sine A on the bottom. Sine B, there's no sine B on the bottom. So can't do anything there. All right, so after all this canceling, what am I left with? Let's try and simplify it a little bit. So on the top, coses have decanceled, so I'm left with sine A over cos A. And on the other one, the coses cancel, so I'm left with sine B over cos B. On the bottom, that whole first term becomes a 1, and then this thing is just a sine A, sine B over a cos A and a cos B. So it does look a little bit easier, and in fact, because we divided by something kind of unique, it's left us with a whole bunch of sine over coses. So can I translate those to tangents? So you see this little thing is a sine A over cos A. So that can get changed to a tan A. Right, tan is sine over cos, so this thing gets changed to a tan A. The other one is a sine B over a cos B. So it's going to change into a tan B. So this will be a little bit easier to remember now. Then we get a 1. And then look at each of these. Notice how I've got a sine A here and a cos A here. I can pretend that those are being divided, and then it gets multiplied by a sine B and a cos B. Well, each of those can change into their own little thing. So the first one changes into a tan A, and the second one changes into a tan B, and they're multiplied. And so that is our compound angle for tan. So we're going to include that over on the sideboard. So if I'm here, I'll go over and write it on, or if not, maybe someone can write that onto the sideboard so that we have it at our disposal. So tan A plus B equals tan A plus tan B over 1 minus tan A tan B. So now the natural question is, what about tan A minus B? So I can do the exact same steps. So if I was going to do tan A minus B, I could say it's sine A minus B over cos A minus B. Use all the same steps, And you can feel free to do this on your own. You're going to do all the same process that you did over here. You're going to do over here, except when you're first line, instead of substituting A plus B, you're substituting A minus B. But you're going to come down. Similar things will cancel, and I'm sure you can figure this out. The pattern is the same. You see that it's for A plus B, you have plus on the top. So obviously for minus, it'll be minus on the top. And then on the bottom, you have 1 minus tan A tan B. So opposite operation here. And so we're going to do opposite operation here and make it 1 plus tan A tan B. And then that is your 6th compound angle formula. And again, I'll put this on the sideboard, or if someone wants to put it on the sideboard, then they can. All right, so now we've got 6 different compound angle formulas. The one for cos A minus B, cos A plus B, sine A plus B, sine A minus B, and then tan A plus B and tan A minus B. So what this will allow us to do is answer questions like the ones we did before. Except we can do them with tan now. So we're going to do the exact value of tan pi over 12 and try and figure out the exact value. So our strategy will be exactly the same as yesterday, just when we go to substitute, we'll be using the tan formula. So it's a good chance to practice what you learned yesterday. So let's think about this. And remember, pi over 12 is 15 degrees. So we're going to change it to a compound angle of 40 minus 30. Or sorry, 45 minus 30. We don't have a special triangle for 15 degrees, so we have 45 degrees and 30 degrees. 45 is pi over 4, 30 is pi over 6. So very similar to what we did yesterday, except we're doing with tan. So instead of tan pi over 12, we're going to change that to tan pi over 4 minus pi over 6. This is now a compound angle formula for tan. We just proved it. It's up on the board now. We're taking the tan of two angles and subtracting them. So we're going to use the subtraction one. So it's tan A minus tan B over 1 plus tan A tan B. A being pi over 4 and B being pi over 6. So just substitute. So tan A, or tan pi over 4, minus tan pi over 6 all over 1 plus, opposite operation here, tan pi over 4 tan pi over 6. So we're going to need to go to our special triangles. I'll just do them up at the top here. Pi over 4, 1, 1, root 2. And the other special triangle is pi over 3 and pi over 6, 1, 2, root 3. So what I need is pi over 4 and pi over 6, but I'm going to take the tan of them. So tan pi over 4, so there's pi over 4. Tan is opposite over adjacent, so it's 1. Tan pi over 6, so there's pi over 6. Opposite over adjacent, so it's 1 over root 3. All over 1 plus, okay, tan of pi over 4 I just figured out was 1, and tan pi over 6 is 1 over root 3. So this is a pretty good answer. 1 minus 1 over root 3. On the bottom, obviously 1 times 1 over root 3 is just 1 over root 3. So we have that. So that's a pretty good answer. However, we can make it look a little nicer by rationalizing the denominator. So remember last unit, sometimes your textbook would rationalize the denominator to make it look a little bit nicer. So we're going to do the same thing here. It's okay on these ones. If you do that, if you forget, I don't think I'm probably going to stress out too much. But if I multiply everything by root 3, it does make things look really nicely. So 1, so this times root 3 is just root 3. But the beauty is, so that's times root 3. If I times this by root 3, guess what happens? They cancel and you're just left with 1. So minus 1. Same thing, times this by root 3. Okay, well that doesn't change much. But timesing this by root 3, they cancel and you have a 1. So you do see how that one is a little bit easier to read. So same strategy last year, or last day. We don't have a pi over 12. We don't have a special triangle, so instead we convert it into the compound angle of two other equations, or other angles, ones that we know. So pi over 12 is 15, so it's 45 minus 30, or pi over 4 minus pi over 6. Since we're asked to find the tan, we're going to use the tan version of it. Okay. So let's try it for 7 pi over 12. You can pause and try on your own if you wish. This is tan 7 pi over 12. Well, 7 pi over 12. 7 times 180 divided by 12 is 105. So this is 60 plus 45. So that's pi over 6 plus pi over 4. Oh, sorry, not pi. 6 pi over 3 plus pi over 4. All right, so change this into a compound angle of pi over 3 plus pi over 4. I've got tan, so I'm going to use the compound angle formula for tan, but it's plus. So it's tan A, or the first term, which is pi over 3, plus tan pi over 4, all over, and then 1 minus, so opposite operation, then multiply them. Tan pi over tan A, tan B. Go off and use my special triangles. Tan pi over 3, so there's pi over 3. Tan is opposite over adjacent, so that's just root 3 over 1. Tan pi over 4, so tan 45 is just 1, so that's that. On the bottom is 1 minus. Okay, that's root 3. That's 1. So don't need to do much simplifying here because it already looks pretty good. Root 3 plus 1 over 1 minus root 3. Those are your compound angles formulas for tan, used exactly the same way. Okay. So that's that. If you really wanted to try something that combines yesterday's work and today's work, or just yesterday's work, here is a warm-up question you can try. I'm not going to do the answer or solution right here, but this is where you're taking the spread out version and you're going to simplify it first. So use one of the formulas to simplify it, and then once you simplify it, you have to find the exact value. So if you want to see the answer, you can go on to Moodle. Okay, so take this, simplify first. So using one of the compound angle formulas backwards will simplify, and then you'll end up with a number that you go off and find the exact value. So you got to use all your cast rule related to acute angle and all that sort of stuff to get your final answer. I will tell you, if you don't want to go off in Moodle, that the answer eventually is root 3 minus 1 over 2 root 2. Okay? All right, so that's enough for today.